Hi everyone, welcome back. In the second video, we're going to be looking at creating our first classes about the NPC world spawners. So that's going to be our base and main class. That's basically going to drive all the NPCs that are going to go around in the world. So basically it's going to be one of the most important classes, and that's going to hold most of the information. So let's start. I'm going to create it based off an actor. So let's right click, create a new blueprint class, an actor, and let's call this NPC spawner, or I guess we can call it uh, faction handler. That's a better descriptive name because these are going to basically be the base of of all the factions. So although we don't really have any kind of assets to use, I think I'm going to just give it a box. Well, I guess it's a static mesh, just so we can visually see where they are placed, although it's not really important. They don't need to be there, but it's just so we can see it. So I'm gonna add a cube. There you go. And let's go over into the class defaults because we need to set up some of the replication. So first of all, we're going to make sure that it replicates. The server is going to derive all of this information. So we need to make sure that the clients stay updated, so it needs to be replicated. Then I'm going to make sure that it is always relevant. So basically what the always relevant does is, because the world is so big, if one of these actors is like down there, so it's so far away that basically the game is going to ignore it if we do not have the always relevant. That's also has to do with the net call distance squared. This basically will be ignored if we have always relevant. That's basically I want that because this is one of the most important classes, as I said, and I want the clients to always receive the information. This is This is especially important. For example, if you have a map, a world map where you click M or something, and then a 2D map will appear. Then if there's like squads and NPCs moving out of this faction handlers, you would want that to always be updated to all the clients and everything. So that's why I'm going to make them always relevant. But one of the things that I want to do is basically make sure that the net priority, I'm going to leave it at 1, but the net update frequency, this is how many times per second this actor is replicated over the network, and I'm just going to leave it at the normal 1 time per second, since it's not really that important that this is like updated a lot of times. Well, I'm gonna leave it at 2 and leave minimum net update frequency. This is used when the bandwidth is overloaded, and I'm gonna leave that at 1 time per second. That's basically everything that we need to do over here. The net dormancy is going to start as awake. That means that it will, once this object is spawned or loaded in the world, is always going to start replicated. We could set it to, dormant, so we could, update it through code. But I guess this one, we can leave it at always being replicated, so it's going to start awake. So let's drag one of these faction handlers into our world. It doesn't really matter where right now. I guess one of the things that we want to do as well is make sure, well, I guess it's not really derived from here, but we need to make sure that we have some navigation mesh over in the world. So normally, because the world is so big, if you use the navigation or the nav mesh bounds volume, like the memory and like that would take, and like the time for it to load would be too big because the world is so big. So we're going to use something called navigation invokers, which are basically derived from from the characters, or any actor. You can add it as a component over here. So if you go into our player character and add a component, and you can choose navigation invoker, and this will basically be that a nav mesh will always be generated around the players when they're playing. So that's important for like the NPCs to be able to walk around visually, in using the nav mesh. So you can see the navigation radius over here. We can leave it at well, I guess we can increase this a little bit to, I guess, 10,000, and leave the tile removal radius to 15,000. So this is the generation radius, and then this is the radius where the tiles would start to be removed as we walk away from the area. I guess this is, it can be the same, but it's better if we leave a little bit of an offset. So let's leave it like that. And I think we need to go into the project settings, we can search on the details. Let's go navigation, and where is it? Generate navigation only around navigation invokers. I'm gonna say that to be true. And I'm gonna want to, well, I guess we can see all this stuff if we find the navigation system over here. There we go. And I want to go into the navigation mesh. I'll make sure that the runtime generation is dynamic, so it changes at runtime. And there's the other settings that you can change over here, like the default for the project. And we can basically test if this works if we drag a player character into the world. And then I don't know if you need to simulate it. Oh, I think we still need to drag a navmesh bounce volume. But then this won't be used. It will just be used where the place where the navigation can be, generated inside. So this won't actually be generating anything. It will be the character, but we still need to put this on the map. So let's just make sure that if we do like 1,000, 2,000 in this case, that works. And then like 500. Let's do a little bit more so we make sure it covers everything. There you go. So now if we go into over here, we can see everything is covered. If we now drag the player character in, there you go. You can see the navigation would be generated, but only inside our radius that we defined over here. And then if we move this character aside, it's going to generate. So at runtime, this would be, as we walk away, you can see the tiles are generated around only the player. What this does, it basically allows us to generate navmesh at runtime. So that's good because if we have like doors that we can open or close, or if the level changes dynamically, this would update according to that, and it would build around that, the meshes on the world. But it also allows it to only have navmesh on the memory and like around the players. So you don't really need navigation where it's far away from the players because, as I said, we're only going to have actual pawns and characters spawned in if we are close, to one of the NPCs locations. So yeah, we're gonna leave that like that. I'm going to press P to add that. By the way, I'm pressing P to see the navigation, or you can go into show and toggle that over here. There you go. So let's close that. And because it is generated around every player, so if you spawn like multiple clients, if a client goes over like to that side and the client go to that side, it will work the same way. So I don't know if you know like State of Decay. On co-op, you need to stay close to the host. I don't think it's because of the navmesh, it's more because of the world loading, but it kind of applies to this way that we're doing it, where people can go around to any sides of the map separated. Players don't actually need to stay together. So if you're doing a co-op game, you don't actually need the players to be close to each other. And this actually also works for competitive games like with more players. So whenever players go independently, everything will be generated correctly. So yeah, let's go to our faction handler right now. So right now let's start doing um, well, some of the stuff over here. So we're going to be filling out some variables. And I think for this, I'm going to create structs, which are basically data tables. So I'm going to right click on the content browser, go into blueprints and choose structure. I'm going to do s underscore and then faction details. And this is going to be useful because now we can keep the faction details inside the data tables, which will be better than we have like 1,000 variables different over here. So I think it's better. So let's do like a faction name. Now this won't really matter for the tutorial, but it's just an example, like a faction color. Let's choose linear color, and then I guess we can do, I don't know, I want to put something over here. I guess it doesn't really matter. We can do a faction. No, I guess that's okay. We can leave like that. Okay. It's just as an example. So, in your game, if you have like different stuff, I don't know, like if you want your faction to have more details, like different types of buildings that they can construct or something like that, then you will add stuff over here, or like different traits for different factions. You can have like all that information over here. But it's not the point of this tutorial, so I'm just going to leave it like that. So I'm going to create a new variable in the faction handler, call this details, and change the type to faction details. So I guess we can make this instance editable and expose on spawn, but I also want to make this replicated. So if you're just going to use this as basic information and you're not going to change it at runtime, you can leave this not replicated. But I want to do an example, like if you want to change the faction color in game, like for example, if it's like the player's faction, the players can choose the color and the name, then we'll need this to be replicated so it updates to all the clients and the server. So I'm going to leave it as replicated, although if you're just using this as base information, that's not going to change our runtime. You don't need to do that. But now we can go over here into the world where we have this drop then, and we can click on it, and then you have the details over here, and you can do the faction name, which I'm going to call random faction, whatever. And we're going to use the faction name as like the ID for the faction. So make sure that there are no, like if you drag and drop like 10 of these, make sure they all have different names, or if they have the same name, make sure it's on purpose so they're actually from the same faction, so they'll kind of work together. That's kind of the point. And then the color we can do like a red or whatever. I guess we also need something over here, which is going to be um, NPC classes. And I'm going to make this of the type characters. So in my case, on my game, I want all the NPCs are going to be in game. I want all of them to be from the character class. So like in my own personal project, I already have like a master class for NPCs, but for this purpose, um, I'm going to do it from the base character. So you can actually choose any type of character to go in here. Doesn't really matter. And yeah, so if we go over now we can choose the NPC classes that this faction can spawn. So imagine if you have like I don't know, a melee guy or like different type of NPCs. So a giant. Let's imagine a fantasy game. If you have like a giant and then you have a dwarf class and everything, you would add all those different classes over here. Right now we only have the master AI, so I'm gonna leave that. It's going to be the only pen, but I created an array for it so you can have a little bit of randomization when spawning stuff from over here. And yeah, that's it. So now comes the other stuff, which is going to be a little bit more complex. So now at even begin play over here on our fraction handler, what do we want to do? Well, then it's going to depend on the game. So for example, in my game, I want the factions to spawn like squads or individuals that go and look for loot in the world. In this case of this tutorial, we don't really have any of that, so I'm just going to give them the objective of going to a random point in the game. So I guess I'm going to set this up by well, I guess we need to create another class first. So this is the faction handlers that are going to hold information of the factions, and it's going to spawn squads from over here or individuals, as I said. But those squads and individuals are going to be represented by another class, and it's not going to be the characters. So if you remember in the last video, I said that the NPCs are going to be really far away, are going to be represented. Are going to be represented by something that is not like rendered and is not going to be a character, which is expensive. So I'm going to create a new base actor again, and I'm going to call this. I'm going to use the terminology of squads a lot. It's kind of so we understand. So this is like the squad leader that spawns like really, or like the the commanding officer or something like that, like the army. From the army there come squads, and the squads can have individuals in them. I'm gonna kind of use that terminology to make it a little bit simpler. So I'm gonna call this the squad handler. There you go. So, the faction handlers are going to spawn in individual squads. Now, in the squad, you can have a unique NPC in it, so it can represent only one NPC, or you can have like a group. What this does is that imagine that you have 500 NPCs and you want, a group of 10 of them to go to a position. So you're only going to spawn one squad handler that's going to represent the 10 NPCs. And then if the player goes close to the squad handler, that's like going through the map, it will spawn the 10 individual character classes that will spawn in a row, and then you can fight with them, and etc. So this is kind of the point. So instead of having like one squad handler or one handler for each individual NPC, we can actually group them together to make this even more efficiently. So let's go into the class defaults. Again, we need to replicate this. Now I'm going to set a little bit higher network frequency because these will actually need to move through the world. So I'm going to do a 10, and I'm going to do a 5 on the minimum net frequency. And it's also going to be always relevant, but I actually want to replicate the movement because these will be moving through the world. So I want them to be visual, or sorry, I want them to be replicated, the movement, and I will add a visual, which I'm going to add a static mesh for now. Now in game, this wouldn't have any visual, so you could see them like through the the world map, like the 2D world map from above. You could see them moving around or something like that. But because we don't have any of that, I'm just going to use a 3D mesh, and I'm going to use a cone for that, so it's a little bit different. Oh, sorry. There you go. Just gonna make sure it doesn't have any collision, because this is kind of, it's supposed to be invisible and it's not supposed to interact with anything. Let me go into custom, make sure it doesn't do anything. Okay, that's fine. So this squad handler is only going to have one thing for now. We could probably spawn another struct over here, but I'm gonna just do an array, and this is going to be the squad members. Let's call it squad members. It's a little bit easier to understand. So this squad handler is going to hold squad members, which are going to be of the type character. There you go. And these would actually be... Well, now I'm thinking, yeah, let's do class references for now. Now, the problem with sorry, the problem with using base characters, like base classes, are like, imagine if, so if you go close to them, they spawn, then you go away, and they despawn, and then you go close to that, and they spawn again. Using classes, they won't hold any information from the previous encounter. So, for example, if they get damaged by you, they are going to not all that information because the base classes cannot be modified. So I'm going to create another thing. Yeah, I think I'm going to actually create another struct for that. So I'm going to create another array in here that's basically going to hold the information that we want to be saved. So think about it like a save game file that's going to save between encounters, for example, the health of each individual squad member. So let's do that. Let's create a new structure, struct underscore squad member attributes. And right now, I'm just going to do health. Let's make that a float. And let's create a new variable and call this squad members attributes. And this is going to be an array of squad member attributes, which in this case are only going to hold the health, but So we need to make sure on the code, once this gets filled in, so let's imagine we get 5 squad members in this array, we need 5 squad member attributes over here. So the index needs to match. So, but yeah, we'll do that through the code a little bit later on. Let's just make sure the squad members do not need to be, or I guess they do need, because we're going to generate the number of squad members at runtime, so we want this to be replicated. And the attributes, obviously, because they're going to change throughout, also needs to be replicated. Yeah, I think that's it. So let's go into the faction handler. And what do we want to do over here? So let's create a new custom event server. And let's call this, I guess, launch squad. So every time this, when we call this event, we're going to basically, so I guess spawn is a better word instead of launch. We're going to spawn a new squad into the world. Let's do it on the server. And what we want to do with it, well, we can add a new parameter. Let's just do a location for now, so a vector. And this is going to be target location. Now, if you're doing a game, and you're going to have different objectives for the squad. So imagine, for example, in my personal project, I might want them to scavenge the world. I might want them to go and kill another squad. I might want them to attack another, faction's base. In this case, I'm just going to use a simple vector. But if I wanted multiple tasks, I would create a blueprint and enumeration. And each enumeration would have, well, I guess we could do a structure as well. But I'm not going to do that. We don't need to complicate this further. But you will have, multiple. You could like select from a list what you want to do. For example, attack base, and then you also need to identify which base do you want to attack, and then you'll pass that information through here. But you know, it just depends on your game. I guess that's what I'm trying to say. So I'm just going to use a simple vector target location for now, and the spawn squad we're going to do spawn actor from class, and this class I want to spawn is going to be a squad handler. And always spawn ignore collision. Now the spawn transform is going to be character location. The rotation doesn't really matter. Now what do we want to do on the reference? I guess we could store this, store every squad handler. If you want to use anything with it, I guess we don't need to do that for now. We can come back later. Now the difficult thing is, how do we move these faction handlers, actors that are supposed to be invisible? Right now they have, they have the cone, but we want them to be, kind of be invisible. But how do we move them around without a navmesh? Because they're not a character, they don't have, they don't have like a character movement component to move. So we're going to do mad movement, which basically, because it's an invisible actor, we're not going to be close to them as players. Sorry, I'm a bit confused. There you go. We're not going to see them as players, so we can just get them. We can just move them in a straight line from where they are to their target location. We only need to worry about spawning the individual characters if the players get close. So I think we can do something like, well, first of all, let's go into the squad handler and let's go target location. So we need to pass on the target location to over here. So let's make this a vector. I'm gonna make it replicate in case we need to change it. We probably don't need that, but just editable expose on spawn, and let's actually expose all these variables. And we are exposing them so we can override them over here. So if you right click, refresh, now you need to assign all of this. So you could use some kind of algorithm. You have like in your faction, you have like manpower left or something, or like individual characters or individual squad member classes that you have available. And then you could like draw from that. I'm just going to do a simple make, for the example, and select the master AI. And like these squad members, I'm just going to choose or add, I guess 3 of them for now, but you can do whatever you want. And the squad member attributes, we do the same thing. So just make sure that the number of these match and the attributes match to whatever you want. So in these attributes, you could also have like stuff like his name, or how much stamina does he got, stuff like that if you want. That's where you would add this kind of stuff. Just one for each. I know this looks ugly. Like when I'm like implementing this into my project, I'm going to have algorithm that chooses this for me based on faction settings that they have, like the manpower stuff like I talked about. But this is just so we got something going on right now. The target location we pass through from over here, and I guess we don't need to fill that. So now what we do, let's make sure we call that server spawn squad. So right now, when the game starts, I guess we can do a delay like a second. So after the game starts, after a second, we're going to spawn a single squad. And if you want to spawn multiple, you can just do a for loop. I guess we can do that. So we're going to spawn, I guess, first in X1 and 3. Let's spawn 3 squads. Let's get random. Well, I guess we can do that, but so normally what we'll do, we'll get a reachable point in radius. So this uses a navmesh. Obviously, as we did before, we are not going to have a navmesh covering the entire map. So this is where we'll get references from like buildings or target points that will drop through the map. But I guess let me see something. Let me get an empty actor. There you go. So let's see from this point. So okay, because the landscape is so big, I'm just gonna do something, um, you know, random vector. But is it random vector or? Yeah, I guess it's random vector. No, that's not what I want. Well, I guess we can do this a different way. I'm going to split so it divides into floats, and I'm going to do a random floating range. I'm going to create 2 of them. So the Z in this case is always going to be the same because the world is flat, and it's going to be at 100. So let's just put that in. I guess the Z doesn't really matter because there's the faction handler that is sorry, the squad handler, because it's invisible, doesn't have collision, doesn't follow the nav mesh. It doesn't need to go through the ground. You can actually make it go, like above the ground or below the ground, because we only need to figure out where the ground is when we actually spawn in the physical characters. But I guess I'm gonna leave it at 100 for now. So like that and like that. And I'm just gonna do a minimum of 25,000, and that's 25,000. And do the same thing. I guess I can do this. So it's just going to choose a random, it's not going to, find from the full. Like landscape, it's just going to find something more close to the middle. But it doesn't really matter for this case. So with this, what we do, yeah, so after we do this, we're going to spawn. This is going to get random directions for each one of the 3 squads. After we spawn the squad handler, well, now we need to do the movement logic on the squad handler. So event begin play. Let's create a new custom event, server underscore move to location, or move to target, I guess. Oh, sorry, I left something over here. There you go. move to simple. Oh yeah, I don't think we can use these. Does this uses? Yeah, I think this needs a pawn or something. Yeah, it needs a controller, which an actor doesn't have. Okay, well, we're going to need to do this another way then. Um, I guess what we can do, I guess the timeline is not going to be that good. Well, I'm going to do something which is probably not very a good idea. Well, I need to find a better way to do that. But for now, I think I'm going to use the event tick. I know in games we should never use the event tick, but I will figure out another way, more optimized. But I think I'm going to use this for now just to try out something. In case you didn't notice, I don't really prepare this beforehand. I kind of go with the flow. You know, I think I explained it in previous videos. I like to, reach problems in the middle of the video so I can actually, uh, you know, show my thought process on how to problem solving. For you guys, I think that's very important. Even more important than you understand what I'm doing is you need to figure out how to solve problems, because that's going to appear, all the time. Well, anyway, what I'm going to do, I'm going to use a Ventic and I'm going to use a vector interpolation. And the current, we're going to get the actor location. And the target is going to be our target location. I guess we can do that over here. The delta time, I'm going to pass that through a pen over here because I'm going to call that server move to target over here. And the interrupt speed is basically going to be how fast does this squad handler moves. So we don't want this to be unrealistic fast, so we need to kind of simulate, your character, the character speed, or if they're moving in a vehicle, you can make this faster. But I'm gonna make 5 for now. I think that's probably a bit too fast. I'm gonna do it 1. It's fine. And then we just set the actor location. And I believe because let's teleport. Teleport basically ignores collisions, but we don't really have collisions. But just to make sure, this will make it so. I forgot what I was going to explain. I think I was saying that we can use the set actor location because we are replicating movement, and because we are using the set actor location, we should get automatically the location replicated to all the clients without needing to do a multicast. I'm pretty sure that's right, so let's try this out. If I didn't forget anything, so I'm gonna use the simulate button for now. Let me find this. Oh, okay, it worked, but they're moving way too fast. Okay. Um, Let me do 0.0. Yeah, I'm probably going to come up with some kind of math, you know, to figure out the interp speed to like a normal character speed. So it's kind of the same. But for now, I'm just going to eyeball it before I figure that out. There you go. So now they're moving away to their target point, and obviously you wouldn't see this. And if the characters are this close, this wouldn't be happening because you know, the players would appear. So that's the first thing that I'm going to do. Well, I don't know how long this video is. Let me just check OBS. Well, I can't really see the time here, can I? Okay, well. I'm going to wrap up soon. I'm just going to create the rest of the components on the squad handler. So I'm just going to do a sphere collision. This is going to be the only collision I'm going to have, and it's going to be an overlap all. So I'm going to use this collision to detect where players are in there or not, or the players are close or not. That's what I want to say. So let's just make sure this block all is, or overlap all. There you go. I just want to make sure this is roll dynamic, and it also overlaps projectiles. And let's make sure, well, this is going to depend on your game, but you want to make this big enough that you don't see the characters spawning in. So if you make this too close, like 10 meters, once you get close, they are just going to spawn in front of you, so you're going to see that. But if you make it too big, you can overlap the players with too many squads at the same time, and they might spawn like 100 physical characters. And that's probably depending on your behavior trees or AI codes, how optimized they are, it might be too much. So it's kind of tricky. We probably need to figure out, while testing, but just so we can see everything working correctly, let's do uh, 10 meters. I know, it's stupid if you think of using this in the game, like with 10 meters, but just for testing. That's what I want to say. Um, so I'm going to choose this, call this player detection, and I'm just going to prep begin overlap, prep end overlap. So this is going to be like the main things that we're going to use. So once a player gets in, we're going to add them to an array of players inside, and once the players get out, we remove them from the array. And if the array is bigger than 0, it means that a player is close, and we spawn the physical characters instead of using this invisible actor. And we also need a variable called pause squad handler. And this is going to be, so if what do I want to say? If the physical characters are spawned in, we don't want the squad handler to keep moving. Otherwise, once you go away from the engagement, um, and like you open the map and you see the squad handler resumes its movement, it's already going to be, at its location. And you don't want that. You want the squad handler to stay where, the physical characters are. And then once the physical characters disappear because the players moved away, you want it to resume to the target location. So we just need to pause the squad handler, and we're going to do that on the event tech over here. So if pause squad handler is false, then we're going to move. And if it's true, we're not going to move to target. We're just going to wait until the players move away again. Yeah, I think I'm going to leave it for this video. We could continue doing the code to spawn the physical squad members and stuff, but I think it's already a big video. So I'm going to leave it here. So yeah, in the next one, we're going to finish up the squad handler thing and actually make sure that the player detection works. And once the players get close, we actually spawn the physical squad members. We set the pause squad handler to true, and then once we move away, we set it to false, and uh, the squad handler continues, basically. That's, I think, what I'm going to try to achieve in the next video. So yeah, thank you guys so much for watching, and you can check out my Discord. It's going to be in the description if you want to talk or whatever. And yeah, see you guys in the next one. Bye bye.